This video is about solving quadratics in Vertex form. Some of you already saw this the other day, some of you didn't. Either way, you should watch the video and take notes, because this is an easier and more useful way of solving quadratics than factoring. So we're going to start with an example. Let's say a rocket is fired into the air, and the height of the rocket is modeled by the function h of t equals -5 times t minus 3 squared plus 45. When will the rocket hit the ground? Well, hitting the ground means when the height is 0. So we'll set the function equal to 0 for the height, and we get 0 equals -5 times t minus 3 squared plus 45. Now we have to solve for t. So instead of factoring, which would involve expanding the t minus 3 squared, distributing the -5, putting it into standard form, and then trying to factor it, we can do this in a much more straightforward, easy way by just trying to isolate t and get t by itself. So how do we do that? Well, we need to go in reverse order to what's being done to t. So if you look at t, we see t minus 3, and then it's squared, and then it's times -5, and then it's adding 45. So we think in reverse order from that. So our first question is, what does this have to be? What does -5 times t minus 3 squared have to be so that when you add 45 to it, it becomes 0? Well, that's easy. The answer is -45, because -45 plus 45 is 0. So that means that -5 times t minus 3 squared has to be -45. So the next question is, well, if -5 times t minus 3 squared is -45, then what does t minus 3 squared have to be? Well, -5 times that has to equal -45, so that has to be 9. Because -5 times 9 is -45. So that means that t minus 3 squared has to be 9. Okay, well, if t minus 3 squared is equal to 9, then what does t minus 3 have to be? That squared has to equal 9. But that has two answers, because 3 squared is 9 and -3 squared is 9. So we have t minus 3 can be 3, or t minus 3 can be -3. Either way, if we square it, we get 9. So now we ask, let's look at the left one, what does t have to be so that when you subtract 3, your answer is 3? Well, t has to be 6. And on the other one, what does t have to be so that when you subtract 3, you get -3? Well, the answer is 0. So t has to be 0. That means that the rocket is on the ground at 0 seconds and 6 seconds. And of course, if we graphed h of t, it would look like this, and we can see that on that line is when h is 0, and that happens when t is 0 and when t is 6. That matches what we just discovered. Another same example, different question. Now, can we see when the rocket will be 25 meters high? So again, when will the rocket be 25 meters high? Well, this time instead of setting the function equal to 0, we set it equal to 25. So again, we ask, what does this part have to be so that when you add 45 to it, you get 25? Well, the answer is -20, because -20 plus 45 equals 25. So that means -5 times t minus 3 squared has to be -20. So now we ask, if -5 times t minus 3 squared is -20, what does t minus 3 squared have to be? Well, it has to be 4. Why? Because -5 times 4 is -20. So we just discovered that t minus 3 squared has to be equal to 4. So now we ask, if t minus 3 squared has to be equal to 4, then what does t minus 3 have to be? Well, t minus 3 could be 2 or -2, because 2 squared is 4 and -2 squared is 4. So t minus 3 is 2 or t minus 3 is -2, which makes t having to be 5, because 5 minus 3 is 2, or t has to be 1, because 1 minus 3 is -2. So that means the rocket is 25 meters high at 1 second and at 5 seconds. Again, we can look at the graph. Where is 25 meters high? Right there. And where does that happen? Right there, which is at 1 second, and right there, which is at 5 seconds. So right now, you need to write down the steps that you should follow when trying to solve a quadratic equation written in Vertex form. Write down the rules in words.